650 light-years away, in the shoulder of Orion, a cosmic monster is waking up. Betelgeuse, one of the largest, brightest stars visible to the naked eye, has entered the most unpredictable phase of its life. And for the last few years, this giant has been behaving in ways that challenge every model of stellar physics we thought we understood. It dims without warning, then brightens to record levels. It twists, bulges, collapses, and erupts with colossal waves of plasma the size of entire planets. For scientists, Betelgeuse has become the ultimate paradox, a star too chaotic, too unstable, too strange to neatly fit into any textbook definition of a dying red supergiant. But recently, something extraordinary happened, a discovery so unexpected, so game-changing, that it forces us to rethink everything we believed about Betelgeuse's instability. Because deep inside the chaos, hidden behind boiling plasma and drifting dust shells, researchers have found evidence of a companion star, a gravitational partner, a long-suspected but never confirmed sibling shaping Betelgeuse's destiny. And if this discovery is true, then the mystery of Betelgeuse's strange behavior may finally be solved, and the implications stretch far beyond this one star. This is Cosmic Nexus, and today we're venturing straight into the heart of Betelgeuse's chaos, uncovering how a hidden star, violent internal physics, and a turbulent outer atmosphere all collide to create the most unstable giant in our cosmic neighborhood. To understand the scale of what we're dealing with, imagine Betelgeuse replacing our Sun. Its outer surface would extend beyond the orbit of Mars. Its volume, large enough to fill the space of several 100 million suns. Its surface, a roiling ocean of convection cells, each larger than the entire orbit of Earth. But none of this fully explains why Betelgeuse behaves the way it does. Stars this massive typically follow predictable cycles, but Betelgeuse refuses to cooperate. In 2019, it dimmed so drastically the world thought it was about to explode. But instead of dying, it came roaring back, brighter than ever. Why? What disrupted the star so violently? What pushed it to eject a mass of material hundreds of times larger than our moon? And why does its shape keep distorting as if invisible forces are tugging at it? Those questions baffled scientists for years. Until now.
The turning point came when researchers realized they weren't just observing Betelgeuse, they were watching the interaction of two stars. For decades, astronomers suspected Betelgeuse might be part of a binary system, but every attempt to detect a companion ended in frustration. The supergiant's surface is too chaotic, too bright, too turbulent. Any small star orbiting nearby would be drowned in the glare. But when Betelgeuse dimmed in 2019, something incredible happened. The turbulence cleared just enough for new instruments to see subtle patterns that had always been hidden. Teams at the Harvard-Smithsonian Center for Astrophysics and the Flatiron Institute both independently tracked Betelgeuse's tiny positional shifts, movements so small they were invisible to older telescopes. But these shifts weren't random. They followed a repeating pattern, a gravitational oscillation, a wobble. Something was pulling on Betelgeuse in a rhythmic, cyclical way, and that something wasn't inside the star, it was orbiting it. A faint, compact companion star, now nicknamed Betelbuddy, circling Betelgeuse approximately every 6 years. Not a massive supergiant, not a dense neutron star, but a sun-like object dimmed into near invisibility by Betelgeuse's overwhelming brightness. This discovery explains one of Betelgeuse's most confusing mysteries, its inconsistent brightness cycles. The star doesn't just pulse from internal changes. Its outer layers physically shift due to gravitational tides from its companion. Betelgeuse is being stretched, pulled, distorted. Its massive convection cells are thrown off balance. Its dust streams are redirected. Even its massive eruptions suddenly make sense. The Great Dimming wasn't just a random surface event. It happened in a region where tidal stress from the companion star is strongest. But the mystery deepened when astronomers studied Betelgeuse's apparent rotation. Based on ALMA data, the star seemed to spin at nearly 5 kilometers per second, far too fast for an object that large. If true, the star should have torn itself apart, but it didn't. which meant something else was happening, and the answer was hidden in the star's surface, in the boiling, rising, collapsing plasma that defines Betelgeuse's chaotic appearance. High-resolution simulations revealed a stunning truth. Betelgeuse's fast rotation wasn't rotation at all. It was turbulence, on a scale humanity had never observed before. Betelgeuse is so huge that each convection cell is the size of Earth's orbit. These cells don't rise gently, they erupt like cosmic geysers, moving at tens of thousands of kilometers per hour. When these massive bubbles rise and sink, they produce Doppler shifts identical to those produced by a rotating star. But because Betelgeuse's surface is blurry even to our best telescopes, the turbulent motion blends into a smooth gradient. It looks like rotation, but it's not. And here's where the puzzle pieces come together. Betelbuddy's gravitational pull disrupts these convection cells. It amplifies turbulence in some regions, suppresses it in others, and shifts the patterns of rising and falling plasma. This creates the illusion of rotation. It creates the asymmetric brightening. It creates the chaotic shape. It even explains why some regions suddenly erupt while others remain calm. The entire star is effectively in a gravitational wrestling match with its companion, two massive bodies locked in a dramatic cosmic dance. The Great Dimming? Caused by a region where convection and tidal stress combined, ejecting a colossal cloud of material that then cooled into dust and blocked our view. The sudden brightening? A consequence of hot material rising in regions where gravitational compression forced deeper layers upward. The surface distortion? A star whose outer layers respond like liquid under the pull of a nearby mass. In other words, Betelgeuse is not just unstable, it is being disturbed. It is being stretched, shaken, and sculpted by the presence of another star. And as we study these interactions, we are learning far more than just the future of Betelgeuse. We are watching, in real time, how binary companions reshape the death of a massive star. And that brings us to the question everyone wants answered. Is Betelgeuse about to explode?
The truth is both reassuring and surprising. Betelgeuse will explode, but its chaotic behavior does not mean the end is imminent. In fact, the discovery of its hidden companion suggests that much of the instability we've been seeing is external, not internal. The Great Dimming wasn't the start of a supernova, it was a dust cloud pushed into our line of sight. The brightening wasn't a death throw, it was a rebound from gravitational compression. The rotational anomaly wasn't a collapse, it was turbulence amplified by orbital tides. So does this mean Betelgeuse is thousands of years away from exploding? Possibly. Some models say yes, that the core is still burning heavier elements and won't collapse anytime soon. Other models say no, that we may be far closer, perhaps within a few centuries. But here's the remarkable part. When Betelgeuse finally does reach the end, we will know. Not from dimming, not from brightening, not from dust, but from neutrinos, ghost-like particles released in the core's final seconds. They will reach Earth long before the light from the explosion does. That neutrino flash will be the universe whispering, "It's happening." And then, hours later, the night sky will bloom with a new light. A supernova so bright it will be visible in daylight. A cosmic beacon that casts shadows at noon. A spectacle humanity has not witnessed in over 4 centuries. But don't worry, Betelgeuse is far beyond the danger zone. Earth is completely safe. What we will witness is not destruction, but revelation, a star's final masterpiece. And thanks to the discovery of its hidden companion, we'll understand this masterpiece better than any supernova in history. Because Betelgeuse is not just a dying giant. It is a binary colossus, a system shaped by gravity, turbulence, and the relentless physics of stellar evolution. A system whose secrets were buried in chaos until now. And as we continue exploring this extraordinary star, one truth becomes clear. Betelgeuse isn't just changing,
It's teaching us